Hi, this is Jeremy Jansen with the February 2010 issue of Reason Wizardry. This month is going to be quite a bit different than anything we've done before with Wizardry, and that's because I'm going to be going outside Reason to show you some other programs and how they can interact together with Reason. And specifically what I'm going to be showing you is how to sample your VST instruments into Reason. So whether you have, native instruments, FM8 or Massive, which we're going to be specifically working with here, or something else like Zebra, all the way to contact-based sampled instruments, anything, any VST instrument, how to sample it into Reason in the most high quality way. And these are my internal techniques that I've been using to create sample-based refills like viral outbreak, like recombination. So there isn't a lot of compromise. This is exactly, for the most part, how I'm doing it myself. And so that requires me to show you some other programs that you may not or probably don't already have. So the programs that I'm going to be working with are Extreme Sample Converter and Wavelab. And Extreme Sample Converter is just an awesome program for converting your samples from one format to another. But beyond that, it's really great for recording new samples, whether that's from VST instruments or from hardware instruments, like say the Virus TI that I recorded for Viral Outbreak. It's an awesome program and it's very inexpensive. I highly recommend that. Wavelab is obviously a larger package that isn't going to be an impulse purchase. I know that there's some limited, I think Wavelab Lite or something like that, that's limited versions that are available that may be able to do what we're going to be working with today, which is primarily looping in Wavelab. But if you don't have Wavelab, it's likely that another audio editor that you may have access to can do some of the same looping tasks, like SoundForge. The free Audacity I have not tried, Adobe Audition. So I'm going to just show you how I work with the programs that I use and how I get the best quality, and hopefully you can extrapolate that into working with your own software, or perhaps using this as a recommendation to look for different software that'll work better for this kind of thing. Alright, so that covers the intro to this material, so let's get started with it. I'm going to start off by sampling something from Native Instruments Massive. This is from our patch collection Data Bank 2, and it's called Chrome Bass. So let's just hear what it sounds like first. Okay, so it's a quickly decaying, somewhat digital bass. So the first thing you have to do is prepare the sound itself for sampling. And that means that in general, you want very minimal effects. So this sound has delay on it. We need to get rid of that. Other than that, it's a fairly static sound. What you want to do is minimize the change between notes, because we're going to be recording multiple notes, and if every note sounds somewhat different, whether that's from a filter LFO or something else, it's going to make the entire sample set not consistent enough all the way through. So this one, if we just play some notes, it does seem to have an LFO effect. We have to find where it's routed here. Okay, looks like we have LFO5 routed to pulse width. So I'm going to just mute that. And as well to bend. Okay, that sounds pretty static. So it should be suitable for sampling at this point. So now I'm going to bring in Extreme Sample Converter. That's what program I use to actually sample the patches. So I'll bring that up here and show you how to get started with it. We need to set our source format and our destination format. We're going to set the destination format as SFZ, and our source format is going to be VSTI converter. Okay, now that brings up another window. And here we're going to want to load our massive VST. I've already done that, so don't need to actually load it. So quickly to go through this, I'm not going to go through all the details. Obviously, if you have this program, you can look through the manual. But hold is how long each note is going to record. Release is after, say after this 15 seconds is up, it will record the release phase of each note. It's generally not necessary. It's nice to have a little bit there so there's like a buffer in between each recorded note. So in this case, what we have is a sound that decays rapidly. So it's not going to need the full 15 seconds of recording. So if we click the menu here, there's actually an auto trim function, and that will just trim the recording once silence begins. So it'll save us the trouble of finding the start and end of the recording. All right, what we have down here is the key map itself, so which notes we're going to record. So when we talk about recording multi-samples like this, this is kind of up to you how many notes you'd like to use. Of course, you could record every single note on the keyboard, and that's going to produce the closest copy to what you're recording. But that's going to use a huge amount of memory. It's going to be unwieldy to work with. If we did have to loop any of the samples, it would just be a nightmare. So I'm going to show you what compromise I generally work with when sampling synthetic sounds. I like to work with 3 samples per octave. Okay, so I'm starting on C1 and I'm going to end on C6. And oftentimes after I record, I'll find that I don't need maybe the highest and lowest notes. Sometimes the highest and lowest notes just don't sound good, so you can eliminate those afterwards to save on memory and make any additional processing simpler. Okay, so we've set up our key map. We've got our sample right here. That's a good starting point. If you really wanted to work with higher sample rates, you can. 24-bit I would generally use, but then I would usually downsample that using a bit depth converter to 16, and that kind of goes beyond our scope. So I'm going to just stick with 16-bit here. So now we're pretty much ready to go. The nice thing is that sampling VSTI instruments is very fast. So you'll see how quick it is here. So I'll just put in the name of our recording and start. And that's that. We've got a recorded sample set. So let's move this window aside, and you can see it right here. And you can see how it's laid out across a keyboard right here. So if we click on these, we can hear them. I should also mention one more important setting. We want to use the auto clip setting so that if the sample does clip, and that obviously means going over the digital 0 decibel value, it'll re-record that note. So you don't have to worry about setting your volume a little too high and clipping. And you also want to use the normalize option. I'm normalizing every sample to 0 decibels, but in some cases you can also use the normalize patch as well. Okay, so we've got our entire sample set here. Let's just click convert. I'll just create a folder here. All right, so it's written all our samples and we're ready to load that into Reason. We now have recorded our samples, so we can go ahead and load those into Reason. So I've pulled up an NNXT already here, and we're going to open it up, and we're going to load the samples that we recorded. Okay, so you can see they've all loaded into the key map section here. So this is where it gets a little bit complicated. There's multiple ways to proceed from here. We need each sample to be mapped just to its own key range. And for starters, I'm going to show you the shortcut, and then later I'm going to show you the more reliable and high quality way to do it. So the shortcut is, okay, I'll try to make this not scroll off for you. It's set root notes from pitch detection. So when we do that, NNXT takes a moment and it scans through each sample and tries to determine the proper root note. So you can see here it set the root note uniquely for each note. Now it's not always 100% accurate, and in this case it hasn't been. This note right here, 036, is its MIDI number, and it's our lowest note, which you probably remember was C1, while here we've got C0, so it's probably mapped everything an octave lower than it should be. We'll find out once we click. This may scroll off for you. It's just below the previous option, Auto Map Zones. Okay, now you can see everything is laid out. We want it to be laid out like this. If any of the zones were overlapping, we'd know that there's a real problem. But what we've got is just everything an octave too high. And that's pretty easy to fix. We've already got this in a combinator. So I'm going to just open up the programmer, click on the NNXT, and transpose everything down 12 steps. So now everything should be properly in tune. Let's just play a couple notes and see what we've got. It sounds pretty good to me. I'm going to also mention, while we're talking about tuning, you can see right here that the fine tune value in cents has been offset to -2. And that was done by the pitch detection. And that's another flaw to using this method, in my opinion, because it will set these small fine-tuning offsets on every note. Of course, we've recorded these notes from a pitch exact virtual instrument, so we don't want any fine-tuning offset at all. So we can select all these notes and then switch them all to 0 fine-tune. That's not going to make a really big difference, but if you really care about your samples, you're not going to want anything slightly off-tune. I know I don't. So that's our lowest note, C1. And it sounds okay, so I wouldn't have removed that. And then we can go all the way up to C6. So we've recorded a pretty good key range. I'm fairly happy with that result. So I'll just quickly show you a few things that you could do now that you've got these samples in the NNXT. The first thing I do is set some velocity control over the volume level. Maybe add a little bit of release. And perhaps some filtering. And then maybe recreate some delay, since we had to take some delay off in order to sample this sound. Just some quick multi-tap. So I'll save that patch for you. You're going to get those samples as well. So that really didn't take very long. That's if you have access to Extreme Sample Converter and some interesting virtual instruments that you'd like to get into Reason, it doesn't take very long at all to get started, and you can get a pretty effective result. Okay, so we started off fairly simple with the first sound we recorded, in the sense that it was a decaying sound. It didn't require any looping. It wasn't sustained. So a lot of sounds that you're going to want to record are going to be pads or leads or something with a long sustain, and that's what we're going to get into here. So once again, we're going to work with Massive, and this is another sound from Data Bank 2 called Padding, and let's hear it first. So it's a digital pad, pretty soft, sustained, so it doesn't have a lot of rhythmic aspect to it. If it had a lot of tempo synced elements, we'd have to remove those. It's already nicely just sustained and similar the whole way through, so we don't have to make a whole lot of changes, except we've got delay here, which I'm going to turn off. And there's also a reverb, which is really kind of up to you, but I would prefer to turn reverbs off and then add them later in Reason. So we've got that turned off. Still sounds pretty good. The only other change we need to make is actually turning down the release of the amp envelope. And that's not a complete necessity, but I find it safer for sampling. If you have a long release, it is possible that the release could overlap the start of the next note that's recorded. So just to avoid any sort of possibility of overlapping notes and that kind of a mess, we can turn down the release stage. All right, so we are bringing back Extreme Sample Converter here. And I've already got Massive loaded. So now just looking at our parameters here, 15 seconds. That's probably a good enough time to hold this pad sound. You want to have enough sound recorded that you can loop a chunk of it and it's not going to sound really quick and obvious. So actually, maybe we'll just raise it to 20 seconds. Everything else should be okay. We'll turn off the auto trim option. I don't think it would trim any of the notes since they're not decaying, but just in case, just to take any possible variations out of the process. So now we're ready to go. We're going to use the exact same key range, so 3 notes per octave. That doesn't need to change. So the next stage is going to be to loop these samples. And there's a whole variety of ways you can do it. You have probably heard of auto looping. I'm not really in favor of auto looping. I've never had very good results with it. There is an auto looping mechanism in Extreme Sample Converter, so you're welcome to try it. In the end, with all the sampling I've done, I've only found good results with manual looping. And you can use a huge amount of programs to do that as well. You could use SoundForge, probably Audacity as well. Here our sampling is done. We'll just bring this back in. You can see our key range is set up. Let's listen to a sample. How about C3? It sounds good, so we're on the right track. I'm going to take a slight break and we'll get into Wavelab right afterwards. All right, now I've got Wavelab up and I've got it loaded with our padding waveforms that we've just created. So the first thing I'm going to do is unrelated to looping, and it's clicking either E on your keyboard or going to sampling, edit sample attributes, and it's parse name into key. And I do that for every sample that I'm working on because what it does is embed the root note information from the file name, so this is MIDI note 40, into the sample itself. So then when you load this sample into Reason, we don't have to use that auto pitch detection routine that is sometimes inaccurate and also messes up the fine tuning. So you put in a little bit more effort while working in Wavelab, and you have a much easier time importing the samples to the correct notes in Reason's samplers. Okay, so now let's move on to looping this sample. So the first thing you need to do is listen to the sample and figure out approximately where the sound is ready to be looped and stops changing. So for instance, if there's a filter sweep triggered by an envelope that lasts for about the first 5 or 6 seconds, we wouldn't want to start the loop until that motion is over and the sound is somewhat static. So let's listen to this sound and see where it'd be an appropriate place. This sound is pretty static the whole way through. There's not a whole lot of envelope action and really noticeable motion. So this shouldn't be a problem to loop, let's say, starting at 10 seconds to about 16. And that's probably, you could probably get away with a shorter loop that's even closer to the start of the sample. But just to ensure that we have a really good example, I'm going to use more sample than I normally would. So now let's right click, create loop region. And now if you go to sampling or push L, you can bring up the crossfade looper. And this is what's really important. Basically, using the crossfade looper, you can fine tune your loop points, and you can also crossfade the loop, which means that it puts a little bit of the start of the loop at the end. It basically smooths the loop points so you get a seamless loop. And this is what I've used on almost all of my samples. There's other solutions for getting seamless loops, but this has really worked well for me. So when we start out, we can see this is how good our current loops are out of 1000. So that's not the greatest. What I'll do is click right here, and that will find a better spot for the end of our loop. So anything over 800 I find is an okay starting point for using crossfade. So now we'll go over to crossfade, and these values, you may need to vary them depending on what kind of sample you're working with. For a synthetic pad sample, these are good starting point values, 20% length and 50% shape, halfway in between linear and equal power. So now we'll click apply. And our loop is set up. So now we can listen to it. I always listen to the loops after I've created them, because even though it might look visually like it's going to be a great loop, that's not always the case. In this case, actually, if we open the crossfade looper up again, you can see the quality of the loop since we've applied the crossfade is pretty much as good as it gets. So once again, let's listen. So that's a pretty good loop. Now we can delete all of the sample after the loop. We don't need that. It's unnecessary. It's just dead sample. Because what's going to happen as the sample is played back, it's going to go through everything, go to the end of the loop, go back to the loop start, and once you release the key, it's going to still continue oscillating from loop start to loop end. It's never going to actually play back this portion, so that's just a waste of space. Okay, so now that we've got that, I'll do it a little bit more efficiently on one more sample, and then I'll kind of fast forward ahead and do the rest of the samples on my own. All right, so we've got 044 up. We'll parse the name into the key. Listen to the sample. A lot of times, once you figure out where the loop points should be approximately for the first sample in a set, you can use that as a starting point for all the samples. So I'm going to just take a guess and see if that works. We went from 10 to about 16, so I'll try that again. Create the loop region, bring up our crossfade looper, find a better loop end point, Okay, that's not bad. Apply our crossfade. Okay. Now let's listen to our loop. Okay, so that's as quick. You could get a little bit faster than that, but it is time consuming to manually loop. There's no way around that. But the results that you get, in my experience, are so much better and consistent than auto looping tools that there's just no comparison. I should also mention one more technique if you just can't get into looping. Perhaps you don't have any software that'll do it well. Just some reason why you want to avoid the process completely. Of course, there's one more way to get around that, and that would be to sample a very long length. So for this pad, I could have sampled, say, 25, 30, 35 seconds. However long would be the maximum amount of time that you'd ever be holding down the key. So if I sampled, say, 30 seconds, I probably would never be holding down the pad more than 30 seconds, hopefully. And in that case, you'd never hear the end of the sample, so you wouldn't really need it to loop. Of course, that's just horribly inefficient. You'd never sell samples like that, but for your own personal use, if you have enough RAM to load samples like that, that's a legitimate way to get around the looping problem. And especially if you want to record something really quick that's sustained and get it into Reason, don't want to have to mess around in another program looping. It's a legitimate way to sample a very long length and quickly import that into Reason. Okay, so I'm going to stop that here and I will finish processing the rest of the padding samples on my own. Now we're back in Reason and we're going to load the padding samples into the sampler. So I've got empty NNXT here. We'll go to load sample, select all our padding patches. Incidentally, you can see the sample size we've got here. Our short Chrome base samples ended up about 250K, and our longer sustained pad samples about 2.5 to 3 megabytes each. So quite a bit more size in the second sample set. All right, so we've got them all loaded in. And now here's the great part. Since I took that extra time to embed the root note into each sample, now all I have to do is go down to, see if I can make sure you can see this here. Just scroll down to auto map zones. I don't have to set the root notes using the sometimes inaccurate pitch detection. Just auto map zones, done. Perfect. No fine-tuning problems. Okay, so we've got our sample loaded in. We can make a couple of quick tweaks. Increase the release time because this is a pad. It sounds really good, actually. That's a useful pad that of course, is going to be included in this set, and I'm glad I recorded something that hopefully you can get some musical use out of as well. So a little bit of velocity response, that's up to you. Just show you something else I do in a lot of sample sets, not really particularly pads like this, but a lot of times what I'll do is set up, well, a 12 dB filter works, 12 dB low pass filter. Bring our filter frequency down some, something like that, and then just increase our filter frequency velocity response. just so we have our lower velocity notes having a little bit duller tone. So it's a lot of times it can fake having multiple velocity layers using filter frequency velocity response like that. So here's a low velocity chord and then a high one. And the values vary for each sample set. This might not be optimal, but it's a starting point anyway. And then you could set up LFO to filter. So we'll close that, and I'm going to just also show you if you wanted to use the NN19, and actually I do prefer the NN19 on synthetic one velocity layer sounds, you could easily load the samples in there as well. And it's very important to have used the embedding root node technique with NN19 because it has no automatic pitch detection. So we'll load the samples into here. And all we have to do is right click on here and go to Auto Map Samples. And you can see right there we're correctly split up across the keyboard. And that's the only reliable way I've found to load in samples and automatically get them to map, is to set up those root notes beforehand in a sample editor. So just to expand on why I'd use the NN19 instead of the NNXT for a synthetic set like this, it's much more controllable from a combinator standpoint. If I open up the programmer here and look at the NNXT, it has very few modulation targets. Only the basics, actually, I believe it's just the knobs on the front here. Now if we go down to NN19, it has a long list of modulation targets. So you're able to do more creative sound design using the NN19. The sound quality is close to the same, assuming you have high quality interpolation turned on both. And you've got the ability to modulate this sample start parameter, which can be really useful. I'm not going to talk about that right at the moment. I've got a viral outbreak refill video. I believe it's the second one where I go into using sample start parameter and some basics with it. You guys might already know that or have seen it, but that basically covers why I would prefer to use NN19 for a sample set like this. Obviously, if I had a really heavily velocity sampled piano or something like MK Digital Keys, one of our other refills, that just doesn't work in NN19. So I'm going to delete this NN19. I'm going to just add a few effects onto our sample set. Try a unison, followed by a reverb. I really like the film score patch for pads. So let's see how that sounds. I'll just add a little bit of compression at the end. Of course, you could do anything with this set. I'm just dressing it up a little bit before I save it for you. Okay, so that's from start to finish, sampling both decaying virtual instrument patch and a sustained virtual instrument patch. That brings us to the end of the February 2010 issue of Reason Wizardry. Don't forget, you've got both the patches that we created in Reason and the samples that I created available in the February Wizardry package. So you can experiment with that. You can just use the samples in your tracks. You can do whatever you want with them. I ask that you don't use these samples in any refills or commercial capacity without contacting me. So just be respectful of that. Beyond that, I hope I've opened up your eyes to some of the possibilities of bringing other sounds into Reason that you currently can't, and experimenting with them in sample-based format in Reason samplers. If you have questions about this issue or questions about the software in order to sample into Reason, as always, I welcome you to email those to me. I'm happy to help. Okay, this is Jeremy Jansen. Cheers.